Hi Jeff, welcome back and welcome to everybody watching. This is our sixth episode of our podcast series, and we are doing a continuation of our new product, the GSatMicro Core. This, for me, is such an intelligent product, and it's taken a little bit of time to get used to it and to understand the technology. There we go, Jeff. Thank you for showing us the finished prototype. It's incredible. We spoke about this 2 weeks ago and we've already got a first version. These non-terrestrial network wireless communication systems that are operating and involve satellites as low Earth orbit are going to become so powerful. They're going to unlock so much potential connectivity, and we've got this cutting edge product that's at the forefront of that. And so I thought it'd be great to talk a little bit about the fact that we've now made this prototype. We're testing it, it's working. Last week we looked at the original spec sheet, and now that it's up and running, maybe you can tell us a little bit more about it, how it's going to connect. I know it took me a while to try and understand how roaming charges are going to work and how the networks are going to talk to each other and how this could connect to multiple different satellite networks and provide a user a end case solution that they can use. So please, if you can tell us a little bit more about how this product's going to work.
Yeah, absolutely. So NTN's a very hot topic this year so far, as a lot of satellite players are investing in sort of marketing the name of NTN. But what is it really? It's a cell tower in space, and so you still use a SIM card as you would in any terrestrial GSM modem, right? There's new GSM modems that have, say, Rev 17, 19, 21, and beyond have different capabilities in what they support on the NTN network standards, whether they support GEO, LEO, et cetera. There's some technicalities there. But in this case, this made many of the design decisions for the GSatMicro Core product into this sort of form factor, right? Starting off, right, the backside is a mini PCIe interface to a variety of modems, right? There's going to be competition in the modem manufacturer space of who's going to make the best, the cheapest, the widest supported modem for different regions. There's a whole lot of bands and technical specs and things around each GSM modem option. Our plan is to support laying out a simple, two-layer board layout for selecting which modem you want to put on the back. And this isn't limited to NTN modems either. The GSatMicro Core is really the core IoT product for any network, whether it's terrestrial GSM satellites, NTN, even Iridium, Globalstar two-way, et cetera, right? If the IoT modem fits within this sort of form factor and package, which pretty much all low data rate modems do, right? We can put it on this and interface the main MCU to it, right? So just to touch on a couple of the important GSatMicro Core features, right? What do we have here? We have a USB-C DC inputs with solar panel MPPT algorithm support, a main MCU running Python, 8 megs of flash, Bluetooth, L1 and L5 GPS, accelerometer, gyro, magnetic compass, and external internal flash memory. I think we've got about half a meg of RAM as well, a dual core MCU running a Bluetooth network core, and then the main application core, and all that's running Python that you can write code in a studio environment, right, that you write code, load on the board, and run and debug and develop all of your end-of-line tests and automated tests as well as part of that architecture. So the headers across the front, these are Arduino compatible headers, right, for digital inputs, outputs, ADCs, UART, right, assignable I2C, SPI, etc. are all these pins, right? So you can stack Arduino compatible modules onto this stack up, write your Python code interface to it. There's also a KVIC connector here. This is a I2C interface out to sensors that you daisy chain via compatible wire interfaces. They're just plug and play, and then you write some code to interface to that specific I2C address. You see them most commonly doing visual things like lighting RGB lights, and sensors, humidity, temperature, barometric pressure are all very common sensors. There's like 500 common sensors or so that are compatible with that CVIC interface. Otherwise, a lot of power management and stuff going on the board too, to manage battery power, solar panel inputs, MPPT algorithm, battery charging, fuel gauging, which is all the sort of power control that you need, and also all the high power pathing that you need for the higher power satellite modem capabilities. Right, generally you're talking about in the hundreds of milliamps, and you're talking about an amp or two, right, to get payloads out over satellite. So a lot of power pathing stuff designed into this architecture as well. So yeah, excited to have this as a physical product in hand, and great to hear about everybody's needs and projects behind it.
Absolutely. I mean, this is effectively a way to merge the prototyping with a production-ready core, and we now have this complete solution for IoT business and integrators. And I think, anybody from a student looking to do a project to a value-added manufacturer to somebody trying to build out a project scope or a solution for their end client, this allows them to use satellite NTN and GSM connectivity worldwide. So we've got this plug-and-play modem flexibility, which is future-proofed as well. With all of those connectors, I guess it's pretty easy to just update with the latest telematic standards and be able to upgrade as future products come out. So it's really quite impressive, and I came up with a new acronym while you were talking, so I'm going to try copyright that. And we've effectively enabled the satellite of things. So there was the Internet of Things, and now we have the satellite of things. And I feel like that's what this product's allowed us to do.
Perfect. Let's run with satellite of things.
Well, great, Jeff. So yeah, thanks very much for taking us through the technical specs and some more deep dive into that product. And we'll post the spec sheet for this product with the link in the video. And please reach out to us if you've got any other questions, if you'd like to talk to us about your projects, and we'd love to hear from you how you'd like to use this product for your projects. So thanks for listening. Jeff, as always, thanks for taking us through and telling us about the product.
Thanks.
We'll speak to you next week.